Okay, so in this example, we're given a T-beam with a rope that's attached to the ground here. The ground acts as a fixed support, and we're asked to determine the reactions of the fixed support at point C, given that the tension in the rope is equal to 1,300 pounds. Okay, so we start by drawing our free body diagram. So here we have our T-beam, and here we have our rope that's attached to the ground. Our angle alpha is equal to the inverse tangent of opposite over adjacent, so 0.25 over 0.6, which gives us 23 degrees. And we can assume that the tension is acting in this direction. So here's its x component and here's its y component. And over here we have the reactions of our fixed support. There are three of them because it's a fixed support. So we have our moment, our vertical reaction, call it Cy, and Cx for our horizontal reaction. Now to solve this, we sum the moments about point C, and we call any moment that's counterclockwise as being positive, and any moment that's clockwise as negative. Okay, so we'll start with a 750 pound force. It's counterclockwise, so it's negative. So 750 times 0.5 for its moment arm. 0.5. And this force, it's counterclockwise, so it's positive, plus 450 times 0.4 plus this moment, which acts at C, plus m, and plus this moment, or the force caused by this force. The moment caused by this force, which is, it's negative because it's clockwise, minus 1,300 adjacent over hypotenuse because it's the y component of the tension, minus 1,300 cosine 23 times its moment arm, which is 0.25 plus 0.15 times 0.4 equals 0. So if you solve for it, you will get m equals negative 76 foot-pound. Since it's negative, it tells us that our assumption that the moment goes counterclockwise is wrong. The moment is actually going clockwise. Okay. And next, to solve for Cx, we sum the forces in the x and set them equal to 0. So sum forces in the x equals 0. So we have our Cx here. We have this minus 450, and we have this force, which is the x component of the tension, plus 1,300 opposite over hypotenuse sine 23 equals 0. So if you solve, you will get Cx equals negative 58 pounds. Since it's negative, it tells us that our assumption that the Cx acts this way to the right is wrong. It's actually acting to the left. Okay? Next, find Cy. Again, sum forces in the y equal to 0. So Cy minus 750 minus the y component of the tension, so minus 1,300 adjacent over hypotenuse cosine 23 equals 0. Solve and you get Cy equals 1947 pounds. It's going up. Okay, so this tells us that the reaction at C goes to the left 58, then goes up 1947. So that's our reaction at C, which is equal to the square root of 1947 squared plus 58 squared, which gives us 1948 pounds, equals reaction at C. And this gives us its angle. Angle theta equals inverse tangent of 1947 over negative 58, which gives us 88 degrees. Okay? And the moment is negative 76 foot-pound. Okay, so this is the answer, and thank you for watching.